We're going to be looking at G4, IXL G4 here, which is a review of the interior and exterior angles of a polygon. And there's some formulas you're going to need for this, so if you don't have your notes, you can always Google this. First part of this says, what is the sum of the exterior angles? And so remember we talked about if we were to go extend and we would have this guy, and then we would keep going and we would extend and we would have this guy, and we would extend and we would have this guy. Those would be your exterior angles. But actually this is pretty easy because it turns out that the measure of the sum of the interior angles is always 360 degrees. Okay, the next question says sum of the interior angle measures. So make sure you're paying close attention to whether it says exterior, interior. Exterior, there's 360 degrees always, but that is not true for interior. When we did this in class, remember, we could pick a vertex and we could see how many triangles we could make by connecting all of the vertices together from one single vertex, right? So, it's terrible. I'll just leave it. So you can see here that I created 1, 2, 3 triangles in this 1, 2, 3, 4, 5 interior angle polygon, or we call it pentagon. So remember our formula was n-2 times 180 degrees, where n was the number of sides or the number of interior angles. And the reason it was n-2 is because we found out that you always make 2 less triangles than angles or sides in your picture. And then there's 180 degrees in each one of these triangles. So in this case, it would be 5 sides, right? 1, 2, 3, 4, 5 minus 2 times 180. And we know that 5 minus 2 is 3. And so in this case, I'm just going to multiply 3 times 180. And it does say sum of the measures of all of the angles. And so that's what this formula is giving me is if I were to add this plus this plus this plus this plus this all together, we would end up with 3 times 180 or 540 degrees. Okay, let's do that another time. I won't draw all the triangles this time. It says, what is the sum of the interior angle measures? Again, we're seeing that interior, so we would wonder, okay, well, how many triangles could I make? I could make n-2 triangles, and then each one of those triangles would have 180 degrees on the inside of them, so I just need to know how many sides or angles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. And so that means I could make 10 minus 2 or 8 triangles on the interior of this polygon. And so that would just be 8 times 180. And 8 times 180 is 1,440. Okay, another example where we're looking for the sum of the exterior angle measures, one at each vertex. Again, that's that thing where I could extend in each one. But my exterior, no matter how many sides it is going to be 360 degrees every single time. So that means every time it asks me for the sum of the exterior, my answer is 360. Okay, this time it says find x. And so what it's actually asking me for here is a single exterior angle, okay? So I would say, okay, I know the sum of the exterior right? If I were to add all them together, would be 360. And this gives us a really important piece of information. It tells us that it's regular, meaning all of the angles are going to be exactly the same. So if all of them together would be 360, and there are, if I were to extend all the sides here, there would be 3 exterior angles, right? There's 3 angles, 3 sides, 3 exterior angles. That means I could take my 360 degrees and split it into 3 angles. And so that means each angle would be 120 degrees. So right here, this would be 120, and this would be 120, and as well as this one up here, okay? But it only asked me for this one, so I'm just gonna put 120 degrees. Okay, question this time is, what is the value of x? So I think just looking at it that you know that it's probably 90, but it's okay if you don't. So what I'm seeing here is one interior angle. So if I want the interior sum, okay, so all the angles added together, I would have n minus 2 times 180, okay, my interior sum. And there's 4 sides here, so that would be 4 minus 2 times 180. And then I could just multiply 2 times 180. That looks like 2.180, but it's a multiplication, I promise. And 2 times 180 is 360. So what's happening here is if I were to add all 4 of these angles together, it would be 360 degrees on the inside. And that's only true for 4-sided figures or quadrilaterals, okay? So I want one of these. So to find one interior angle, I take the sum, which was 360, and divide it by the number of sides, which in this case is 4. And so 360 divided by 4 is indeed 90 degrees, which you probably knew without me working this example, but this is the only one where you might guess it without having to do any work. Okay. Okay, so again, we are looking for x, and x is an interior, and I think you can see this time it's not that perfect 90-degree angle, but it's this big obtuse angle. We're gonna have to figure this one out. So we have to start by finding the sum of the interior. Sum of the interior is just a formula. Okay, remember it's how many triangles could I create times 180, or n minus 2 times 180. So what I need to do is I need to come over here and I need to look at the polygon and figure out what's n. Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 in this case. Okay, we got a 9 gone. So that's going to be 9 minus 2 times 180. Or 7 times 180. So again, in this case, we could have made 7 interior triangles and then multiplied it times 180 for each one of those triangles. So I'm just pulling my calculator up here and multiplying 7 times 180, and I'm getting 1260. So what this 1260 represents is, if I were to add up each one of these interior angles, all 9 of them, I would get 1260 degrees. To find one, just one interior angle, I need to take that sum and divide it. Remember, it says regular polygon. And because it says regular, that means they all have to be exactly the same. So we can just take that 1260 and divide it by the number of angles on the inside, which is going to match the number of sides. So that was 9. So I'm going to take 1260 divided by 9, and I'm going to end up with each individual angle on the inside being 140 degrees. Okay, next example, we're looking at one exterior. So I'll do one more of these. One exterior, remember the sum of the exterior, no matter how many sides the figure has, the sum of the exterior is going to be 360 degrees. Okay, so no matter what, could be one, or could be 3 sides, or could be 3,000 sides. The sum of the exterior is going to be 360 degrees, right? And then if it tells me that it's regular, that means every single one of these exterior angles has to be exactly the same. So that means we can split up our 360 degrees however many times or however many angles there are. Well, the number of exterior angles will match the number of interior angles, will match the number of sides in the figure. So I'll just count sides. 1, 2, 3, 4, 5, 6, 7, 8 sides are an octagon. So I'm just going to take that 360 degrees, and to get one exterior angle, I'm just going to divide 360 by those 8 angles. So 360 divided by 8 is 45 degrees. So what that tells me is that every single one of these little exterior angles would be 45 degrees. 45, 45, 45, 45, all the way around. And if I added them all up, I would get 360. Okay, what makes this problem a little bit different is it no longer says regular. So notice here that all the angles now are different measures. So that means we can't use our polygon formulas because our polygon formulas are for regular polygons only. So what we do need to do, though, is we need to figure out, well, not all of our formulas, I should say, but if I want to divvy them out, okay, to find one individual. But what I can do is I can figure out how many degrees should be inside here and then take away everything I know to figure out what I don't know, okay? So we have 1, 2, 3, 4, 5 angles, which means we should have 1, 2, 3, 4, 5 sides, which means we could make 1, 2, 3 triangles, right? So I can still use this formula, the sum of the interiors. So that is n minus 2 times 180. And if you were writing notes, at this point, you would have done this one before. 5. We just found we had 5 sides. 5 minus 2 times 180. And that's 3 times 180. Well, maybe we didn't do this actually. I don't know. I feel like we've looked at that. 3 times 180 is 540. So what that tells me is if I were to add up all these sides, it would be 540 degrees for all of them, okay? Now, because it does not say regular, I can't just divide this by 5 and say, okay, well, every single angle is going to equal 108, because this one's 109, this one's 112, this one's 96, so it's not regular. But what I can do here is I can take my 540 and subtract all of these, and it's going to leave me with however many degrees are left over to go in that missing spot. So I'm going to take 540, and I'm going to subtract all the things that I know. And I'm going to hit pause to make this video not crazy long. Okay, and when I take 540 and I subtract 73, 96, 112, and 109. It looks like it's 150, which is sort of convincing. That looks like a pretty big angle measure there, almost aligned, but not quite. And I could easily check this by adding 150 plus 96 plus 73 plus 109 plus 112 and confirming that it really was 540. Okay, this one is similar. It says find C, right? I think I'm not going to go through the polygon formula on this one because I think we all know that the sum of the interior angles of a triangle are 180 degrees. If you're not sure, if you have forgotten, you can always do your formula n minus 2, which would be 3 minus 2 times 180, which in this case is 1 times 180, right? Because how many triangles are inside a triangle from vertex to vertex? Just that guy. Okay, so now what this tells us is the sum of these are going to equal this. So now I can just say, okay, that's pretty easy then. 43C plus 42 plus 95 are going to give me 180. And I would just add 42 and 95, not multiply. 42 plus 95 is 137. So that will be 43C plus 137 is equal to 180. And then I would just subtract 137 from 180. And I would just start solving this equation until I got C isolated to figure out what C is. And so that would give me 43C is equal to actually 43. And so then just divide by 43, and C, of course, has to be 1. And it does just ask me for C. It could ask me for this whole angle, but it's just asking me for C. And so in this case, C is 1. You guys, this problem popped up, and I think I just snorted. This is crazy. So it's an exterior angle problem. We know the sum of the exterior angles is going to be 360. So we should be able to add every single one of these up and get 360, okay? Rather than write this like horizontally across my screen, I'm about to stack like elementary style when you would add two numbers, but I'm going to pause. Okay, so I have them all stacked, and I color coordinated them for you. 2W plus 2W minus 46 plus 30 plus this plus this plus 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 plus. And I went ahead and put plus signs when it was just a number to remind me that my minuses are negatives and my positives here have plus signs in front of them, okay? So I can add up my 2, 4, 6, 7 W's. And then I would just use my calculator. And just because I like to make things a little easier on myself, I actually usually start with all the positives and then start subtracting the negatives. So for example, in my calculator, I'm going to add 30 plus 39 plus 98. 30 plus 39 plus 98. And that gives me 167. And then I'm going to take away the negatives. So then I'm going to do minus 46 equals, and then minus 50 equals, and then minus 5 equals. And I'm using my phone, just in case you wondered. I got a positive 66. Okay, so now if 7W plus 66 is what I would get if I added up all these exterior angles, and then I know the sum of the exteriors has to be 360. So now I have an equation that I can actually solve here. So I'm just going to do that, and I'm just going to subtract 66 from both sides of the equal sign because I'm trying to isolate W because that's what it asks me for. And that's going to give me 7W is equal to 294, I believe. I should check that because, you know, teachers make mistakes too. Okay. And then just divide that by 7. And that gives me W is equal to 42. And I'm all the way down here in this little corner. Okay. So that's it. W would equal 42. So not as hard as it looks, but tedious. And be careful when you're adding the numbers and combining like terms. Okay, once you get up here, and I went ahead and jumped a level at this point because this video is just going on and on and on. Once you get to this point, it's going to give you words. So you have to know kind of what formula to start with. If an exterior angle of a regular polygon measures 40, an exterior angle, just one, okay, then how many sides does a polygon have? So we have a formula for all of them. All of them together would be 360, all the exteriors together. But then it wants to know just one in a regular. Well, remember, we just took the sum and divided by the number of sides of the polygon. And that gave us an individual angle. Well, they gave us the individual angle. The individual angle is 40. Okay, easy enough. So now all I need to do is solve for n to determine how many sides it would take. So basically, 360 divided by what would give me 40 degrees. You might sit here and guess because you're not sure how to work this problem, but I'll go ahead and walk you through it. So if I want to move divided by n, I can actually just multiply by n on both sides, and that would give me 360 is equal to 40n. And then I could just divide by 40. And n would be, let's see, zeros cancel. 36 divided by 4 is 9. So this particular polygon would have 9 sides. Okay, next one says, if an interior angle measures 144, how many sides? Well, we're inside. We have a formula for that of a regular polygon. So to find out the total number of inside, we did n minus 2 times 180. When it was regular, we said, okay, we can take that total and divide it by the number of interior angles, which is the same as the number of sides, and that would give us one individual little angle. Well, it tells us that an interior angle measures 144 degrees. So that is a single angle. So this is going to be a doozy to solve, okay? So I'm going to, let's walk through it. So I'm going to go ahead and multiply both sides times n. And that's going to give me n minus 2 times 180 is equal to 144n. And now I've got to get rid of the parentheses on this side. So I need to distribute and get 180n minus 360 is equal to 144. Told you it was going to be a doozy. Now I've got n's on both sides. So I'm going to have to get ends to only one side. And I know I'm going to end up with negatives here, but I'm going to go ahead and just subtract 180n from this left side so that I don't have to move two things. So all I'm doing here is when I've got a variable on both sides, I'm just subtracting one of those variables to get rid of it from one side. So that leaves me with negative 360 is equal to negative 36n. And then if I divide, I get n equals 10. I could have sat up here and guessed my ends. It's got to be a whole number, so like you start at 3 and just keep going if you are a little concerned about the algebra in there. But you can solve. This would be the method that you would use to solve. So this one's going to have 10 sides. Okay, you guys, I know that video was a little bit long. I'm going to go ahead and stop it there because I'm getting repeating questions now. If you have additional questions, please request help. I will also take those examples and put them on a Google Doc so that you can have them for reference. Okay, good luck, guys.